Alright, so now we're going to look at geometric series, and a geometric series is just a sum of a geometric sequence. So here's our formula. Just like we had a formula for the sum of an arithmetic sequence, or the so many terms of an arithmetic sequence, we've got the sum of a finite, which just means a sequence that ends, of a geometric series. And so you'll have this formula also on your final exam. So it says the sum Sn of a finite geometric series, a1 to however many terms an they're asking you for, where r is not equal to 1, is this. And the reason r can't equal 1 is because your denominator would then be 0 and it would be undefined. So the sum of so many terms is going to equal a1, then in the top, 1 minus r to the n, and you make sure it's just the r that's to the n, all over 1 minus r. And so a1 is your first term, r is your common ratio, n is the number of terms. And so we're going to look at a couple examples of how to use this formula. So we want to find the sum of the first 9 terms, S9, of the geometric series, or sequence here. So I'm going to go ahead and write my formula down. A1, 1 minus r to the n, all over 1 minus r. And so A1 is just going to be 2. 1 minus r on this one is pretty easy to see that it's going to be negative 4. And you need to make sure that whenever you have a negative r value, you put that in parentheses also. And then I'm going to raise it to the 9th power, and then it's going to all be over 1 minus a negative 4. So when I plug this in, I like to plug it in the top and then the bottom separately, just because it makes it easier. If you're going to plug it all in at one time, then you need to make sure that you put parentheses around that entire bottom section and around this entire top section. If not, it won't work out right. So in order to just avoid that mistake, I go ahead and just plug in the top, the bottom, and then do my division. So I'm going to do 2 times 1 minus a negative 4 raised to the 9th, close my parentheses, and then I'm going to divide by 1. Well, let's go ahead and not do that. I don't want to got ahead of myself there. So here's the top, and so that's going to give me 524,290, so 524,290. And then in my calculator, I'm going to go ahead and do 1 minus a negative 4, and so I get 5 for that. And so I'm going to then do 524,290 divided by 5, and that's going to give me my sum. So that should be 104,858. So 104,858 would be the sum of those first 9 terms. Alright, number 11. So I want to evaluate the series. This is basically just doing or asking me the same thing as finding a sum. Okay, so I'm going to go ahead and write down my formula. S8 equals A1, 1 minus r to the n, all over 1 minus r, and then plug everything that I know in. So 1/2 is going to be A, and then 1 minus to find r. This one may be one where you can see it, or if you can't, then you can do this division. So I'm going to do 1/4 divided by 1/2, and so when I flip and multiply, that's just going to be 2 divided by 1, which would give me 2 over 4, which is 1/2. So my r value is also 1/2. So I'm going to do 1 minus 1/2 raised to the 8th power, and then 1 minus 1/2 in the bottom. And so let's plug the top in first. So 1/2 times 1 minus 1/2 raised to the 8th power. That's the top part, and then you can get that and then divide it by 1 minus 1/2, and so I would get that. And then they're never going to leave it like that. You math fraction it. You should end up getting this 255 over 256. So the sum should be 255 over 256, and that's how you'll see them leave that. And think about it, it should make sense that this is going to be a fraction, since all of the terms that we're adding up are going to be a fraction. Alright, number 12. This has an old lady clause, so we want to evaluate this sum. And just like we did whenever we were working with sums with arithmetic, if I want to find the sum, I'm going to use one of the sum formulas, either the arithmetic or the geometric. And so I need to see whether my sequence that it generates is arithmetic or geometric. And so I'm going to plug in a couple of terms to see that. So if I plug 1 in, that would be 6 times 2 to the first, which would be 6 times 2, which is 12. And then if I plug in 2, that would be 6 times 2 to the second, which would be 6 times 4, which would be 24. And then if I plug 3 in, that would be 2 to the third, which is 8, and 6 times 8 is 48. So I can look and see that all I'm doing is multiplying by 2. So that's going to be my R value. So R is 2, so it is geometric. A1 is going to be 12, and so I'm just going to use this formula. A10, I'm trying to find the sum of the first 10 terms, or not A10, S10, because I'm finding the sum. So S10 is going to be A1 over 1, or times 1 minus R to the n, all over 1 minus R. So this is going to be A1, which is 12, 1 minus 2 raised to the 10th, all over 1 minus 2. So I'm going to plug the top in. So that's just going to be 12 times 1 minus 2 raised to the 10th. So there's the top. Then I'm going to divide that by 1 minus 2, which is negative 1. So I'm just going to divide that by negative 1. It's just going to change the sign. So 12,276 would be my sum for this sequence. And so I think this is easier maybe rather than finding all 10 terms and then adding them up to find this sum. Alright, so one more problem. We've got a word problem. It says, a union contract specifies that each year, or each worker will receive a 5% pay increase each year for the next 30 years. One worker is paid $20,000 for the first year, and we want to know what the person's total lifetime salary is. So anytime you see the word total, it's going to be S. And so we want to find S30 because we're wanting to find the total lifetime salary over that 30-year period. And so I'm going to write my formula, A1, 1 minus R to the n, all over 1 minus R. And so A1 is going to be $20,000. That's what we will make the first year. And so then 1 minus, now we said that if you ever have a 5% or a percentage increase, then you don't want to just write 0.05. You would want to write 1.05 to make sure that you get your entire 100% of what you started out making, $20,000, plus the additional 5% raise. So my R value is going to be 1.05. I'm going to raise that to the 30th, all over 1 minus 1.05 for R. And so then I'm just going to plug this in. So $20,000, 20,000 times 1 minus 1.05 raised to the 30th, and then I'm going to close that parentheses, is going to give me this, and then I'm going to divide that by, I'm going to put this in parentheses so I can divide by the whole thing, 1 minus 1.05, or I could have just typed in negative 0.05, and so then that's going to give me a total lifetime salary of $132,878, and or actually I would just round this to 132,876. I don't know where I got 8 from. Sorry. So 876, and then I'm going to round that to the nearest cent, so that would be 95 cents. So this would be my total 30-year salary for the time that I worked there, and it's really not that good. But that's how you would do one of these kind of word problems. Make sure you put the 1.05 in for R.